Welcome, I'm Nick Tillett, and in this series of 6 presentations I'll be working with Tim Hales and Kevin King to present our Inter-Row Vision Guidance training slideshow. The videos are based on PowerPoint presentations we've been giving in person to our customers for some years. These online versions have been adapted to the video format and will, we hope, enable us to reach more of our customers. We will continue to give in-person training where we can, but we hope these presentations will provide a useful supplement or a convenient alternative for busy people who may find it difficult to find time. In this first video, I will tell you a bit about our company's history and explain some of the basic principles behind how our products work. In subsequent videos, we will examine the hardware, explain the user interface, show how you might go about setting up a new machine and then run it in the field for the first time, and we'll also cover using our service tools to help diagnose faults. And finally, we will cover the configuration editor, a tool that allows you to make changes to preset saved settings to accommodate new crop or machine geometries. You can select the video you need from our website and view it as many times as you want. So let's start with a bit of ancient history, just for your interest. Back in 1993, when computer vision was a relatively new technology, largely confined to indoor artificial environments, Nick Tillett and Tony Hague speculated that it might be possible to use computer vision outdoors to locate individual plants within a field with a view to conducting precision treatment at the individual plant scale. The focus was on machine vision for plant location and tracking, but they made the additional step of operating for an autonomous vehicle, which in the mid-1990s was an ambitious undertaking. The vehicle had no GPS, relying solely on crop rows as a navigational reference, making headland turns by dead reckoning. Individual cauliflower plants were identified by computer vision and tracked until they're under an array of nozzles, where the appropriate nozzle or nozzles were triggered. This video dates from their public demonstration in 1996. They then went on to apply the same technology to the more mundane but commercially important task of guiding inter-row steerage hose. That technology, shown here working on an experimental farm in about 1999, was licensed to Robidome Electronics and Garford Farm Machinery and was marketed as Robocrop from 2001 onwards. In 2005, when the Government Research Institute closed, Nick and Tony formed Tillett and Hague Technology to continue the work. As a private company, they introduced a commercial version of their multi-section guidance, shown here working in a prototype form in 2004. They also developed a novel rotary blade technique for in-row weeding. The first machines were hydraulically driven, but the machine in this video, taken in 2015, was one of the first to be driven electrically, making the process more energy efficient and even more accurate. In 2016, the company developed the current gigabit Ethernet based system as a comprehensive package for implement manufacturers to incorporate into their own products. Several thousands of these systems are now in use on farms around the world. We continue to develop our product, making software improvements in all areas, whilst doing our best to retain backward compatibility with older hardware. So all of our customers, old and new, can benefit from our latest developments. We continue to explore new applications, such as spot spraying, seen here in a crop of onions controlling a variety of weeds, including volunteer potatoes. We are also working on tractor steering, shown here vision-guided hoeing with a fixed front-mounted cultivator. We are based at Rest Park in Silsoe, about 70 kilometres north of London, as tenants of English heritage in this rather nice, stately home. As a strongly R&D orientated company, we do all our own design and software development. The founders and owners continue to work in the business, which has now grown to 10 full-time staff. We are assisted by a network of subcontractors who manufacture our circuit boards and machine our casings, amongst many other tasks. However, for quality control reasons, we do all our final assembly and testing in-house. We will now explain the basics of how our inter-row vision guidance systems work. We start by taking video images from a colour camera. To reduce the effects of shadows, we normally take a green-red ratio to highlight live plant material against the background. We arrange for the camera or cameras to be mounted in such a way that they view the maximum area of crop. The more they see, the more data we have, and the better the performance. Using machine learning techniques, we fit a virtual template constructed using knowledge of camera characteristics and mounting geometry to real crop rows as they appear in the live video image. The more rows that template covers and the longer the length of row in view, the more reliable the guidance. For computational convenience, each frame is split into 8 horizontal bands, and the matching is done in each band. The position of those bands is represented by 8 crosses stacked vertically up the centre of the image. A blue cross indicates a good match. Yellow and red indicate a poor match. The computer then draws a best fit line through those crosses in each video frame to get a best fit for the template. The computer combines these estimates of row position over sequences of images so that the rows can be dynamically tracked from frame to frame in a way that is robust to short periods of low quality data. Ah, but weeds are also green, we hear you say. However, they are randomly distributed and do not fit the template. This makes row following quite robust, and provided the density of live plant material in the row is greater than that out of the row, it should work. The approach also works very well over a wide range of crop growth stages. So, whilst the image analysis and tracking are quite sophisticated, the control is rather simple. If the view of the rows the camera is tracking deviates from central, a correction is made to bring them back into line. If the rows are to the left of the camera, it steers the implement left, and if they are to the right, it steers right. Typically, that correction is via a hydraulic valve and cylinder. The most popular configuration is a rear-mounted side-shifting frame. However, our system can also be configured to control a whole variety of arrangements. Front-mounted, mid-mounted, mid-mounted, whereby the camera is mounted on a fixed part of the tractor frame, giving a clear forward view. The side shift moves independently behind the front axle. Trailed and multi-section guidance spanning multiple independent planter bouts where each independently steered section has its own camera and module, but is controlled from a single cab-mounted console. Implements can also be disc-steered as an alternative to side shifting. A range of proportional and on-off directional valve can be accommodated. Tillett and Hague guidance systems incorporate a proprietary CAN bus connection for additional functions such as manual override and feeler guidance, as well as in-row operations such as controlling nozzles and in-row cultivators. Also, with appropriate hardware, we can connect to the tractor's isobus for additional integration. So, to summarise, our approach relies on template matching, so the larger the area viewed and the more accurate the template match, the better the performance. We use machine learning techniques to help keep that match accurate. Our system scales from large to small machines, but typically we would expect guidance accuracy to be within 1 centimetre. Cameras normally operate at 30 video frames a second and run control loops at even higher rates, so that the guidance remains good up to and beyond the speed that crop and soil conditions normally allow. We hope you found this presentation useful. Remember, this is the first of a series of presentations covering our inter-row vision guidance systems. Look on our website for links to other presentations and additional training material. If you have any questions, please get in touch. Thanks for watching.